it's going, and I'm just double checking on the recording. Unfortunately, last time I did not have enough space on the hard drive, and it was only recording a portion of the lecture. Today I'm making sure that we have enough space. 17 gigabytes, that should be good for a few classes. All right. I am actually in the process of grading the exam, so don't worry if you see your grade changing and it's very low, because I might be just in the process of doing so. So just kind of keep in mind that I'm still doing it. But what I do want to do today is to go over the test, and so you know what the answers are supposed to be even before you get the score. I refer to this session as rubbing salt on wound. It might sting a little bit, but in the long run, it's actually a good thing, because if you don't rub salt on wound or something, to stop the inflammation and infection, sometimes amputation is necessary later on. And amputation, obviously, in this context, means switching a major That's actually more like amputation and then growing a new limb. All right, so we'll go ahead and take a look at the test. I did the first one already. The highlighted portion is my work. So let me just kind of focus on this part here and explain. You know what? What I'll do is I'm going to do this on another spreadsheet, so this way we can see it a little bit better. Just hold it 1 second as I do a copy and paste. Okay, so here's a copy and paste. I'm going to erase the portion that I have already worked on. Okay. And there's a way to erase formatting as well. So if I go to delete cells, it will tell me, nope, not that one. Okay, what is the option? Delete content. There we go. Delete all. So that would also include the formatting, which is kind of nice. That's what I need here. Let's do the same thing here. Delete content, or just use the backspace key. Okay, there we go. All right. This won't take that many rows. It's a fairly short program to trace. So I'll just go ahead and use one sheet, just like in your test. The first part is you have to use your student ID number to determine which values or what values to start with. I will start with the same value as the one in the test. So in the test, the start values, for the example, is 9, 4, 9 for A, B, and C. So I would do exactly that, 9, 4, and 9 over here. And this is already on line 10. I just quickly glanced through, all of the answers, and I think some people started from pre, unfortunately. So that will take a long while to finish the loop. Okay, this is really close to the end already. Okay, so we are just going through two more iterations or so, and then we'll be done. Okay, so this is line 10, and I have just filled in the values of A, B, and C. Now it's time to move on. After line 10, where do we go? We go back to line 2, because that's the first line of the while loop here. Okay, it's a pre-checking loop, so we go back to line 2. And because it is a pre-checking loop, and is a condition to evaluate, we have to indicate whether it is true or false. What do you think? True. X is less than 10 is true because X currently has a value of 8. And then we move on to line 3. Line 3 is checking a condition again because it's the beginning of a conditional statement. This is a multi-branch conditional statement. So now we have to check, X versus A. Is X and A, do they have the same value? It is false. Then where do we go? We go to line 5. Very good. And then this time we check it against B. And how about that? It is false as well. And then where do we go? Yes, we do have to go to line 7. Okay, it doesn't seem to make a lot of sense because, hey, A and C are the same, so if it's not A, it's not the same as C. But the program doesn't look at it this way. The program still has to follow the logic, according to the structure of the multi-branch conditional statement. So we now have to go to line 7 to compare X to C. The answer is false. They're not the same. And then where do we go? We go to line 10. Very good. Because line 10 is one statement that is right after the conditional statement. That's why we have to go to line 10. Line 10 doesn't do much. It's just adding 1 to X. X goes from 8 to 9. And then where do we go? We go back to line 2. We have done this part already. And then we have X is less than 10 is still true. Then we go to line 3 again. X equals A is true this time, right? So if it is true, where do we go?
4.
We go to line 4. Z gets incremented by 1, so it becomes 11. And then where do we go? This is a tricky part, okay? Because this is a multi-branch conditional statement. If you take any branch out of a multi-branch conditional statement, you are done with the entire conditional statement, okay? In other words, it is confusing because line 7 seems to be, hey, that condition is true too, but you don't actually get to evaluate the condition on line 7 because you're taking the branch starting on line 3 already, okay? So that's why you get out of the conditional statement completely. You go to line 10 because that's the statement after the conditional statement. You add 1 to X. X goes from line 9 to 10. You go back to line 2. X is less than 10 is false at this point. And then you get out of the whole thing. And here's post. Okay, so that's how the loop is supposed to go. What I will do when I'm grading, is I'm looking for indications that people understand, various aspects of this code. Okay, the first part, obvious. Yep, go ahead.
For lines 10 and 4, in the comments, can we write the operation?
You mean over here?
Yeah.
Absolutely. You can add more to what I just provide here, as long as it's not conflicting with what I am putting on the projector at this point. Okay. But there are indicators that I'm looking for. For instance, do people understand from line 10 they have to go back to line 2? That's an understanding of how a loop operates. Okay, I'll just go ahead and highlight the lines I'm talking about. Okay, from here, do people understand we have to go to line 3? Okay, because it's line 3 is inside the loop. From line 3, when this false, do we know that we have to go to line 5 and then to line 7? This is one that a lot of people missed, at least in homework assignments. There's one additional statement after a conditional statement, and some people miss that. Do not quite understand that this statement is really after the conditional statement. So line 10 following line 7 is actually important here. And we go back to line 2, reevaluate the condition. And the most tricky part of this one is really here. The transition from line 4 to line 10 is the tricky one, because that's really the property of a multi-branch conditional statement. If one branch is true, you execute the statement of that branch, and then you get out. Okay, you don't follow, you don't evaluate any additional conditions of the multi-branch conditional statement. Okay, and I'm still trying to decide, how I will score the exam. The method I will be using. Because as you can see, it's open-ended, and scoring this can be difficult. I personally really like two types of answers. Types like this, I say, hey, perfectly correct, 100%, and the ones that are completely missing, like no answers, right? 0, done, move on. Okay, the ones that will consume the most time would be the ones that are partially right. I can see there's a little bit of looping here, but it's not entirely right. I can see there's a little bit of branching here, but it's not entirely right. So those are the ones that are difficult to score, at least in the setting of a class. In the setting of working on a job, the scoring will be done by the boss. Anything that is not working is not working. Okay, it doesn't matter. But boss, it is so close. Look at the billions of lines that I have just written. It doesn't matter. It is not working. Right? And if it's not working, your boss or the owner of the company or the board of directors will basically say, it's not working for us either. We cannot sell the product. We cannot make money. Okay? And they have to make the hard decision of letting people go, if the product is not working. So in a class setting, I can understand, it's probably not a good idea to say all or none. Is it working or not? Okay? Because I do want to tell people you do get some of the concepts, but it's not entirely correct. Okay, differentiating between that and someone who just completely did not answer at all. Okay, but just remember, at work, there's no in the middle. Okay, if it's not working, it's not working. Now, what Danny did not mention is, in many other types of jobs, you can kludge. Okay, you can just kind of do a quick and easy and dirty fix on things. Okay, even when you're building a house. Okay, it's kind of shaky. Well, we'll just add a bracket to make it stronger, right? Instead of actually finding out why it is not stable, you just add more brackets until it's stable. So the house may look a little bit funny, as an end result, but it might be actually solid. In electrical engineering, okay, when you design a circuit board and you use an oscilloscope and you say, well, this line is not supposed to be this noisy, having these bumps in the signal. And a lot of times, if you just add a big capacitor to it, it will fix the problem. Because a capacitor is kind of like suspension, in electrical engineering. So if you add a big suspension to something that is vibrating, it will kind of like dampen it out and seems to remove the problem. So you don't really have to find out why it's doing this and do a kludge to cover it up. Okay, in cooking especially, you can kludge things up, right? This meat has been sitting around for 5 days or so. It kind of smells not so fresh anymore. It's okay. We'll just add more salt and spices. Right? In programming, there is no such thing as a kludge. Okay? If your counter is off by 1, it doesn't work. If you use less than instead of less than or equal to, it doesn't work. Okay, so if you exchange the order of 2 operations, sometimes it doesn't work. Okay, it can be the same operations, but if you exchange the order, it just doesn't work. So that's why I think in programming it is particularly important to really understand the concept of doing it right and understanding the concepts in order to so that it works right the first time. Maybe not the first time, but at least get the concept right. All right, so let's move on to the next question. This question is only worth 3 points, so it's not really a whole lot of point value, but I think it is kind of important too. Okay, here's the second question. The second question has this code down here. Okay, if x is less than y, then repeat blah blah blah. Else while do blah blah blah. Okay, and this is the starting point. And once again, depending on your student ID, you pick one of the starting points. Okay, to initialize the values of x, y, and k. In this case, the example has 9, which is using the last sample, 39, 41, and k. So what I'll do is I'll do exactly the same thing here. Copy and paste it to the other side. Okay. And then we can do the tracing. I just need to remember the numbers. 39, 41, 5. 39, 41, 5. 39, 41, 5. And it's not lotto. All right. So now let's go ahead and get started. And we are starting on line 4 this time. Okay? Not from 3, not from line 1, but from line 4. Okay. Line 4 is until x is greater than or equal to y. So that means the first thing you have to do is to indicate the result of the comparison. X is greater than or equal to y is false. Okay, so what do we do? This is a post-checking loop, and it's saying until. But whatever is after until is false at this point. So what do you think we should do? We have to go back. Go back to where? We have to go back to line 3. Okay, not line 1, line 3. Line 3 doesn't do much. It's just decrementing y. So y in this case is 41, and we have to subtract 5 from it. It becomes 36. And then we go back to line 4. X is greater than or equal to y is true. Then where do we go? This is the tricky part. The post. Okay, post is the answer. because we are done with the then branch in this case. Okay? Because the repeat until loop itself is inside one of the branches of a conditional statement. So when you're done with a repeat until, then that branch is done. Then you have to exit the entire conditional statement. You don't go back to line 1. So this concept has to do with nesting, has to do with post-checking loops, and also has to do with evaluating the condition of x is greater than or equal to y. Okay, so those are the 3 concepts that are being tested here, and I'll be looking for those, basically I look at the traces and see if it is reflecting the knowledge that I'm looking for. Yep.
If we check line 1, will we get the whole problem wrong, or?
That is not entirely wrong, but I would say it's a misunderstanding of the whole concept of nesting, which means for this particular test you will still get partial credit, but that misunderstanding can cost you when you're actually writing programs. So you'll be getting a 0 when it comes to nesting, but you will still be getting other points if the other parts of the trace is still correct. Okay, any other questions? And also when I was scanning through the answers, I saw people drawing pictures, diagrams, and that's a good thing. Okay, because the pictures that I saw are mostly correct. Okay, that means people are understanding the concepts, except when they're looking at the pseudocode, it's not really clear how things should be executing. But once they put it on a picture, then it's clear. Oh, okay, so this loop here is just when this loop is done, there's no way to go back to the beginning of the conditional statement, so we have to exit. So that means that technique is working for some people. All right. So here's the second question, which is also only 3 points. I'm moving on to the big guy here. Okay, question number 3 is worth 10 points. And I thought it was an easy 10-point, but apparently that is not the case. Okay, so once again, what I thought was easy was actually not easy. All right, so let's take a look at the question first. The question is, once again, depending on your student ID, the last 3 digits, add up all the digits and use that as the start value of that's the start value of variable y in this case. Okay, find initial value, find n initial value of x to reach each possible branch, not a possible branch. Okay, that makes a big, huge difference. Okay, and perform a full trace, which means starting from pre, which is also already indicated in the trace here, for each possible branch from start to finish. Okay, so I have a lot of built-in redundancy here. Full trace from start to finish, and a pre, that is already written in the form itself. In each trace, fill in the pre-line with the calculated value of y based on the student ID and a value of x that you choose, so that you can get to the branch that you think you can get to. And then you perform the trace. You have potentially up to 5 traces because there are 5 branches in the multi-branch conditional statement. However, some branches may be dead, so you may not have all 5 branches. So the dead ones you don't trace. Okay. Some people are nice enough to kind of give me an explanation of why the dead branches are dead, which is good, but that's not required. Note that the score. Sorry.
Extra credit.
Note the, well, it's not asked here. Note the score. Excuse me. Note the score of these questions does not necessarily indicate the number of reachable branches. In other words, just because 10 is divisible by 2 or 5 doesn't mean there are exactly 2 or 5 live branches. Okay, because I just want to make it clear, because some people will say, yeah, but it's worth 10 points, so I naturally thought it's 5 branches or 2 branches. Cannot possibly be 2, or cannot possibly be 3 or 4. Well, actually, it is 3. Okay, that's why there's a little disclaimer at the very end, just to make sure that people do not misunderstand. Yep.
By dead branches, you mean we can't reach them with any value because of the previous branch, right?
Some of them, yeah, some of them.
Correct.
So what if we trace it anyway? So you fine with that?
You can trace it, but it won't get to the branch that you want to get to.
Okay.
Right? Okay, but the point, the score is based on a few things. One is, did you read the instructions correctly? Okay, did you actually use a correct value for y based on your student ID? It's based on, did you identify the 3 live branches? Okay, and get the x values that can get to the live branches. And 3, did you actually trace it? Okay, so all of those are factors that I would use to determine your score. So what I'll do is, once again, I'm gonna actually do this whole thing here. And this time what I'll do is I'm just going to copy and paste the original code, and then I'll use another spreadsheet to do the actual trace. Okay, so I'll use the same thing here. And we'll go ahead and do the traces on another sheet, because this is just a little bit easier to do it on another sheet. All right, and we'll go ahead and start with comments, because we definitely have conditions to evaluate. Line number, we have the 2 variables, x and y, and also z. Okay. Do you guys have any questions I can answer? Nope. Okay. All right, so we are starting with pre, and I'm going to make copies of this to other sheets too, because there are 3 more of these things. So I'm just going to make copies of that before I fill in the details. Okay, so in this case, in each case, z starts with an unknown value, so it's unknown to begin with. Y is the sum of the last 3 digits, and let me see what the example used in this case. I cannot remember. In this case, it would be 13. Okay, so we'll use that same number. So y starts with a value of 13. And let's take a look at the code. All right, so there we have it. So we have the multi-branch conditional statement, and then we have the starting point. And we want to figure out which ones are reachable. Okay, so typically the first branch has the highest chance of being live, right? So unless the condition itself is always false, the first branch actually has the highest chance of being live. So we'll try that first, okay? So the first branch is saying, okay, we can get to line 2 if we can somehow get a value x that you have to determine that is less than y, which is 13 in this case. Are there any values less than y and less than 13? Yes. 12 would do it, right? Okay, so that's easy. So we'll just say 12 over here, and then we trace it. Okay, this has to be a complete trace from start to finish for each branch. Okay, so we start with line 1. Line 1 compares y and x and y. That is true. We get to line 2. Line 2 is going to assign a value of 1 to z, and we are done. Because this is a multi-branch conditional statement, you take one branch, you're done with the entire conditional statement. Okay, so that's the first example. Are we okay with this one? Okay, so let's look at the next one. Okay, the next one means we are not taking the first branch. Okay, we are not taking the first branch, which means x is less than y is false, right? Now, if x is less than y is false, well, let's think about it. Y is already predetermined. Okay, y in this case has to start with a value of 13. Z is unknown to begin with because that's what we want to figure out. What kind of value is not less than 13?
13.
We can start with 13 itself. We can start with 14. Okay, so let's start with 13 itself. Okay, so here's 13, and I don't even know which branch it's going to go for, but I know this is something that line 2 is not going to pick up. This is not going to get to the first branch. So go to some other branches. Okay. All right. So we start execution on line 1 again. X is less than y this time is false, and because it's a multi-branch conditional statement, we go to the next condition to evaluate on line 3. Line 3 is asking x is less than or equal to y is true. Very good. So now we go to line 4. We assign the value of 2 into z, and we are done. Okay, so that takes care of the second branch. Are we doing okay so far? Okay, now let's go for the third branch. Okay. All right. Go ahead.
Can't do it.
Okay, the third branch is over here. We cannot get to it. Why can't we get to it?
3, 2 interrupts.
Because 2 is in the way, right?
Executes.
It executes first,
First,
it
and then
evaluates, and then it takes that branch, and then we cannot get to line 3. Okay. What about line 8?
To branch 3. To branch 3.
Yeah, we just
Line,
use
is
the
line 6,
number.
branch 3.
Yeah, so line 6 cannot be reached.
Right.
Okay. You don't even have to explain that if it's not asked in the question. For those of you who explain it, it's good because you just make yourself understand it a little bit better. What about line 8, which is the 4th branch of the multi-branch conditional statement?
That's greater than.
Okay,
Yeah.
greater than. Okay, so we can give that a try. Okay, y is calculated to be 13. What value is greater than 13? 14. Okay, we can try 14. So we trace it. X is less than y is false. We go to line 3. X is less than or equal to y is false. We go to line 5. X is greater than or equal to y is true. We go to line 6. Z gets a sorry.
5 is equal.
I missed that. X equals y is false. Then we go to line 7. X is greater than or equal to y is true. We go to line 8. And then Z gets a value of 4. And then we're done to post. Okay? And what about the 5th branch on line 10? Then can get to it because line 7 would catch that particular condition, and then we won't have a chance to get the line. We won't even get to line 9. We won't even evaluate the condition on line 9. Okay? So those are the 3 live branches for this particular test case. Yep.
Okay, so if line 7 and 9 were reversed, we can then get to line 10.
No. If they were reversed, then we'll only still be able to get to line 8. Because equal to is already caught by line 3 in this case.
Right, okay.
Yep.
So they're both just less than or greater than symbols, so it would work.
Say again?
If there was no equals to on those line 3 and line 7, it would work.
If you don't have equal to on line 3 or
And
line
7, you could
on
do the
line
whole
7?
trace. You could do all branches.
No, you cannot.
Oh,
You still cannot.
Still can't, yeah.
Because if you think about it, if you have 2 numbers, the possible relationship between the 2 numbers, just using equal, less than, and that sort of thing, there are only 3 possible relationships, right? There's greater than, less than, or equal to.
Yeah.
And you cannot have a 4th relationship between the 2 variables. So at the most, you can only have 3 branches. Now, you can have less than 3 branches because you can have an equal and a not equal to.
Right.
The not equal to will catch both less than and greater than. So that's why you can have up to 3 live branches in this case, just because you only have 2 variables and they're all checking for equality versus inequality. All right. Any other questions about this one? No questions?
All the 3 answers is correct.
Hmm?
All the 3 answers are correct.
Each one is partially, yes, correct. So I'm looking for all 3. That's what the question is asking. Okay, I'm asking for all 3 branches. Give me all the possible branches.
I think I did the 3.
Hmm?
I think I did the 3 answers.
Okay, very good. All right, so let's move on to the last question. And last question is down here. Okay, the last question, I'm not sure whether it was in this class or my evening class. Some students walk up to me and go, "Did you have a typo here?" Because it seems way too easy to work 4 points. Well, there's no typo. That's exactly what it is. Okay, because I just want you guys to make sure that you guys follow the logic of the code, but not following your instinct and say Tech cannot possibly be asking something this simple. But sometimes I do. Okay, so let's go ahead and work with the 2 cases in this particular question here, and Let me see if I can just copy and paste this entire thing to over here. Maybe it'll work, maybe it won't. No, it doesn't work the way I want it. It's pasting it as something that is embedded, but I really just want to copy and paste the content. So double click it first, then we can go ahead and copy and paste it. Alrighty. Now it's okay. All right. Okay. So in the last question, we are also going to use a part of your student ID to add up the digits, to have a start value of X, and then the other two will be the start value of W. So in this case, W is the first two digits, and X will have a value of the sum of the last 5 digits. In this case, it's a 5 and a 28. So I'm going to start with 5 and 28 here. So we got a 5 and a 28, like that. All right, so we'll just go ahead and trace the entire code. Okay, this is when you start to finish. Start with line 1. In this case, W is less than X is true. Okay, very good. Then we go to line 2. Line 2 is the beginning of a while loop. W is greater than or equal to X is, it has to be false, right? Because it's the reverse of the condition of the conditional statement. So if one is true to get you in, the other one has to be false. Now the question is, what do you do? Most people can probably get to this point here to understand on line 2 the condition is false. The question is now, what do you do? Post. You're done. Okay, and I saw some pictures, drawn here, and I think those pictures really, really helped. Okay, for those of you who drew the picture correctly, obviously. If the picture itself is drawn incorrectly, obviously, it's going to lead you to a path that is not supposed to go. Okay, so I'm going to draw the picture next. Okay, but before that, let me go ahead and finish the whole thing first. Okay, in the second case, okay, according to the instruction, then exchange the initial values of W and X. In our example, make W equal to 28 and X equal to 5. Fill in the initial values in the pre-line, then perform the second trace to its completion or until you conclude the algorithm cannot finish, and explain why. Just because I say, it may not finish, doesn't mean it will not finish. Okay, so in this case, not only does it finish, it finishes in a quick manner as well. So 28 is here, 5 is here. Okay, so we always start with line 1. Okay, so always start with line 1. W is less than X is false. Then we go to the else branch of the conditional statement, which is starting on line 6. Line 6 has exactly the opposite. It checks whether W is less than X. Well, since we knew it was false to begin with, do you think anything would change it at this point? No, we don't have a chance to change anything at this point, so it's false again. So that means we're not getting into the loop, we're exiting the loop right away, but because the loop is the only thing in the else branch, there's nothing else to do in the conditional statement, so we get to post, and we are done also. So that really is as simple, that simple. I mean, that's how simple the traces are supposed to be. The traces are supposed to be. Okay, so now let me go draw a picture to represent the logic, so this way you guys can look at it and go like, okay, so that's how we translate pseudocode into a picture that represents the logic of the code. The overall code is a conditional statement. Is that okay? Does everybody understand the overall stuff is basically a conditional statement? That consists of line 1, line 5, and line 9 in this case. That forms the outermost conditional statement. So we know how to draw a conditional statement. Now the branches may be a little bit big, so I'm leaving a little bit more space here. And the same way with the else branch here, I'm leaving a little bit more space here. Okay? But that's the general shape of a conditional statement. The condition of the conditional statement is W is less than X. Here's the true branch, here's the false branch, and that concludes the picture corresponding to lines 1, 5, and 9. Are we okay? Now, inside the conditional statement, lines 2, 3, and 4 is a while loop. Okay, so I will first start with the general shape of a while loop here. Okay, so a while loop has a way to exit like that, and a way to proceed to a statement that is inside it. But when we're done with the statement inside it, we also have to go back to the beginning to check further. And that's the shape of a while loop. Are we still doing okay? Now we can see that the while loop is entirely within the branch of a conditional statement. Okay, and that's nesting. It's just like when you have folders in a file system. A folder is inside another folder, not partially. Okay, you cannot have two folders overlapping where a file is in this folder, but it's also in the other folder. It doesn't work that way, right? So it's the same way here. One statement is completely inside the other statement. Okay, so if I want to finish this, we have W gets W minus 1, and then the condition here to determine whether to exit or continue with the loop is W is greater than or equal to X. This is my false branch, this is my true branch, and that's how the code is structured. Are we doing okay so far? What about the other side? Kind of the same thing, except the conditions are a little bit different. So once again, we have a pre-checking loop here. Ooh, I'm getting pretty good at this. I can actually do it in almost one stroke. Here we go. I should make a stamp, so I can just go like that. Okay.
Or make a robot do it.
Yeah. Okay, W gets W plus 1, and W is less than X is the condition. This is the true branch, this is the false branch. That's it. All right. So are there any questions about any of the questions, or how to get to the answers of the questions? No questions? All right. All right, so if there are no questions about this, what I'll do is I'm gonna save this to my temp folder. I'll just call this, exam1 answers. And then I'll just move it up to Moodle right away. So file manager, and then get to edit mode over here. Okay. And I'll also put it to where exam1 is, so which is right here. There we go. All right. So now we can get back and continue on our prime number factoring program. And since I did not have a full recording from last class, how many people still remember where we left off, with that discussion? Not a single thing.
A weekend ago.
Yeah, well, it has been a whole week. I mean, that's why it's a little bit difficult for us to remember where we left off. That's okay, no problem. What we'll do, or what I'll do, is I'll start with an example done by hand first, and then we'll try to write the code to actually do it. Okay, so here we go. And let me change the font here so it's a little bit bigger than the default. That would be good. Okay. So what we'll do is we'll do it by hand a few times. Okay. So we'll start with a prime number like 17, and we'll say 17 equals 17 times 1, because the only factor in 17 that is not 1 is 17 itself, because it's a prime number. Okay. That's a property of a prime number. And then once we get to 1, we're done, okay? Because 1 is not even a prime number itself. It's not a composite. Let's try 15. Okay, 15 is 3 times 5. Okay, in this case, I'm identifying 3 is a prime factor of 15. The 5 is nothing more than 15 divided by 3. Okay, which is the remaining portion of the number that I have to deal with. Now I deal with the remaining portion of the number. 5 equals to, well, the only factor I can find in 5 is 5 itself and 1. So it becomes 5 times 1. And now we're down to 1. Nothing else to do at this point. Let's try 16. Okay, 16 is 2 times 8. Okay, so in this case, I'm only identifying 2 is a prime factor of 16. I don't really know whether 8 is prime or not, and neither do I care at this point. I just want to find one single prime factor with each step. So once I have 2 as a prime factor of 16, I only have to deal with 8. 8 is 2 times 4. 4 is 2 times 2. And remember, the second 2 here is not because I know it is a prime factor. It is simply 4 divided by 2. So in the next row, we'll say 2 equals 2 times 1. And then we're down to 1, and we're done. Okay? So I do have to go through this process with these examples here, just so that we understand how to do it by hand. Now, most of you can probably track this type of division in your mind, and instead of having to write it out on a piece of paper. But if the number gets big, then it's really hard to keep track of everything in your mind, and having a piece of paper is helpful. All right, so now we are going to write the actual algorithm. Okay. All right, so let's see what we can do with the algorithm. When you write an algorithm, when you construct an algorithm, the first thing you have to say is, well, is what I'm going to do repetitive? Okay, am I going to do something over and over and over again? Because if it is, it points you in one direction. If it's not, it points you to another direction, and that's a really important distinction. Do you think it's repetitive, what we just did here? Look at this process. It is? Okay. A little bit. Okay. Well, it does terminate. Okay, I think when you said it's a little bit because it's not going on very long, but it is repetitive. The next question you want to ask is, am I always going through the same number of iterations? Is it always like boom, 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 3 times, boom, 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 3 times? No, we get once, twice, and 4 times. Okay, and you can also imagine if the number starts with, let's say, 128. Then it will go 7 times, right? Because it's 2 to the power of 7. So that means the number of iterations cannot be predetermined. It's not a fixed number. Okay, that's a very clear indication that you're dealing with some kind of a loop. Okay, some kind of repetition. That's fine. Okay, so we'll say this is a loop, and when I use the concept of a loop, I will always spell out end loop to indicate the end of it. Now, are we exiting these loops? Are we finishing the operation with each case?
Yes.
It seems like there's a termination with each one. So that means I can probably specify this is a loop, but there is an exit condition. Okay, we do get out of the loop at some point. Okay, so we'll say exit when. Well, how would you describe the condition when we get out of the loops?
We're down to ones.
When the number to factor is 1, right? Because on the left-hand side here, these are the numbers that I'm trying to factor. Okay, so we'll go down here and just explain that in English. When the number to factor is 1, because 1 is not a prime number, it cannot be factored. Okay, that's it. That's my first revision of the code. It doesn't seem like much. I mean, it seems like really vague, and it doesn't seem helpful at all. But it is. Okay, because 1, it identifies we're dealing with a loop. Now, once you narrow down that it is a loop, that means the outermost part of the logic is either a while loop, a pre-checking loop, or a repeat until, a post-checking loop. Okay, that really helps. But the other part that is also helpful is we are identifying when we're getting out of the loop. Now, once you identify when you're getting out of the loop, it will do other things too to help you think, okay, but what do I need to do in the loop? Okay, because that is going to be helpful.
So you're saying that a loop will only have 2 forms that it can take, a pre-checking and a post-checking.
That is correct. Yep. There are other variants of loops too, like a for loop in C, and like a for each, and there are other types of variations.
Are
But they can
those
all
just forms of pre and post-checking?
Yes.
Okay.
They're all basically specialized, forms of pre and post checking loops with certain things that are just kind of syntactically simplified.
Okay.
But otherwise, they're really just pre and post checking loops. So that's why in this class we only focus on the most primitive type of pre and post checking loops, because all the other types of loops are just specializations of the two general ones that we talk about in this class.
Okay. Thank you.
All right. So next we want to say, when you deal with descriptions like this, it's kind of wordy. Okay. So the next thing we want to do is really just to give the number to factor a name. Okay. So we'll say, let the number to factor be variable n. Okay, so this way we don't have to type all over the place saying the number to factor, and so on. So we just call it n, and that's all we're going to do in this step here. So we still have we have loop and loop exit when n equals 1. Wow, look at that! I mean, my program just got a lot shorter because of the use of a variable. Cool. Okay. So at this point, it is very clear that the loop, whether we go for another iteration or not, depends on the value of n. Now, but does n always start with a value of 1? Or do we even want n to start with a value of 1? What is the point of factoring 1?
Because any number can really be divided by 1.
No, but do we want to start with 1?
No.
Are we always factoring 1? No. So n is usually something other than 1 when it's given to us. It's just because we keep doing this process, chopping it down, at some point it chops down to 1. Does that make any sense?
So conditionally, n cannot be 1 to start.
It doesn't make a whole lot of sense, right? Yeah. It might be 1, in some cases, but in general, it's not 1 to start with. It's something, usually a larger number, right? Okay, so that means n equals 1 is usually not initially true. It's usually some bigger number. What that is telling you is whatever we do in the loop is changing n. Does it make sense? I don't even care how we are changing it, but I know it is changing it. Because otherwise the loop is not going to exit. Does that make any sense? N starts with a value that is not 1, and we're exiting the loop when n equals to 1. So that means, unless this is an infinite loop, that means whatever we're doing in the loop is changing n itself. Now that is important, okay? I can do that deduction just because the condition involves n and no other variables. The other side is 1, which is a constant. Now on the other hand, if it's n equals m, or when n is less than m, then you have two variables to handle. Okay, you can change one but not the other one. You can change both of them, to make the condition true. But in this case, it's really clear. Okay, we have one single variable, that is the exit condition. So that must be the only variable that must be changed when we go through each iteration. Does that make any sense? So what I'm telling you is not really syntax or the behavior of the code. I'm telling you, how to think about programming itself. How do you analyze the problem and say, well, knowing this much, what is the next step? Okay, use whatever you have at that point to guide you to take the next step. Okay, so now we are ready for the next step here. Okay, and the next step is really looking back at our examples here. So in the first example, in the first one, we have 17 here. So that's what n was, when it's given to us, and then it becomes 1, and then we get out. In the second case, n equals to 15 to begin with, then it becomes 5, then it becomes 1. In the last case, it was 16, then it becomes 8, then it becomes 4, and so on. What are we doing for each iteration? If you just focus on one single line, let me just focus on this one line here. What did we do with this one line? Just describe it in English.
Divided by.
Okay, divided by 3. Okay, so there are two steps involved. The first step is to find 3 first. Now, all of these are very simple, okay, and that's why it did not even occur to us that we had that step of finding a factor first. So maybe in our examples, we should also include something that is not obvious, okay? So I'm going to cheat a little bit here with my phone so that I can find one that is not obvious, so that you guys cannot say, oh, it's 3, okay? And I have to find my calculator, okay? All right. I really like this, the calculator, and this is a simple one, has a welcome screen that says slide left and right to access more content, blah, 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 blah. I need to learn how to use a calculator. Okay, so let's pick something that is kind of not so simple. Okay, this is a good one. All right, so let's start with something like that. It's all the obvious rules of thumb or heuristics do not work on this number, okay? So what is the first step?
7. 7.
Well, give it a try. If you divide 391 by 7, you get 5, and then 41, you get 5, 5 with a remainder of 6, 55 with a remainder of 6. Doesn't work. Okay, exactly. Now that's good progress there, okay?
It's not an even number.
So you actually have to do something to find a factor of this number. Okay, so maybe we should write that down, okay? Find a factor first. Find a prime factor. I don't care how you do it, but that's what we're gonna do. Okay. All right, so let's write it down. So we'll say loop and loop. So we basically keep the same thing as last time, except inside the loop here, we describe what we are trying to do for each iteration, okay? So we'll say find a prime factor of n, okay? All right, so let's say we did find the prime factor here. It is 17, okay? That's one prime factor. What do we do with this? We divide it, okay? Very good. So after the division, we get the other part, right? And in this case, it's actually 23. Okay. So the next step, after we find a prime factor of n, then what we'll do is divide, print the prime factor that we just found. And then the last step is what? What do we do with n itself? What becomes the next number that I try to factor? Divide n by the prime factor that we just found. Okay, that seems to describe exactly what we did, right? Okay. Now, what this step is showing you, or what this particular example is showing you, is instead of trying very simple and trivial examples, try something harder. Okay? Because a lot of times, if you only try very simple examples, we can use what we call the eyeball algorithm, and instantly find the answer. It's like there's nothing to it. Okay? But you know what? The computer doesn't have eyeball algorithm. You have to describe things in terms of the operations that you can actually perform, right? So that's why you have to make kind of more examples that you cannot intuitively know the answer, to really try out and identify the steps that you need to perform the operation. Yep.
So would you almost have to use counters to find, for a real difficult number like 399, start with 1 and 391, and then
Yep.
would you essentially use counters with the loop to?
That's exactly right. But remember, this whole chapter, this whole topic is about top-down design, which means, we don't want to deal with that logic, okay? Just ask someone, right? What is a prime factor of 391? I don't care how you get to the answer, just give me the answer. That's basically what top-down design is, okay? You don't want to deal with that level of detail at this point, okay? You can say, well, I just want to know a prime factor of 391. You can explain to me how that is done later. Okay, but right now I just want to get it done. That's basically what we're doing here. Okay. So now we have an algorithm that looks like this. Doesn't quite look like the algorithms that we have been dealing with in this class, but getting closer. So the next step is to look at this code here and go like, oh, that's kind of confusing because we have, find a prime factor, and then, throughout the program we have the prime factor we just found, the prime factor we just found. Maybe we should just name it, okay, as a variable. That can probably help us simplify the program a little bit and make it more clear too. So we'll just say let the prime factor that we find be f, okay, f for factor. So in this case, then we have to change the program a little bit and just say find a prime factor f of n, so that we know in the first step we actually find a value for variable f. The rest of it becomes a lot easier. Print f, divide n by f, okay? But when you say divide n by f, you're basically saying, okay, we end up with a quotient. What do we do with the quotient? Well, we want to put it back into n, because that becomes the next number that we are doing to factor. Is that making any sense? Okay. So now we just say, oh, instead of this, we say n is n divided by f. Get rid of that. I think we're getting closer to making this program actually, doable. Okay, because we're cleaning it up, and we are only one step away from getting it all done. At least at this level. Okay, so now I think we are almost done, except for one thing. We have to determine whether this is a pre-checking loop or a post-checking loop. Okay, are we going to check the condition first, or are we going to check the condition later? So what you have to decide, or the way you decide this, is to say, well, to evaluate whether n equals to 1, do I have to go through at least one iteration for n to be meaningful? Or does n come in with a value that I can use already, and I don't need to go through at least one iteration? That is the question that you have to ask. Because in a repeat until loop, which is a post-checking loop, you have to go through at least one iteration. In the case of a pre-checking loop, which is a while do loop, you do not have to go through at least one iteration. You can basically say the condition is false to begin with, skip around the whole thing. So that really is your question. N comes in already initialized, doesn't it? So that means I can use a pre-checking loop. Okay. So we'll go ahead and do that part here. So we'll change the code here to use a while loop. I'm leaving that empty just so that you can tell me what it is supposed to be based on the code that we already have written so far. Okay. So here we have the code that we have written so far up here. The condition that we have been using as an exit condition is n equals 1. So what do we put here? N is greater than 1. Okay? Or not equal to 1. Because we have to invert the logic. We have to invert the logic because in the previous case, when I say n loop exit when blah blah blah, it is an exit condition. But in a while loop, it is a stay in loop condition. Yep.
Wouldn't it be preferred to say n is not equal to 1, because if n comes in as 1,
then it will just skip around the whole thing and not do a
Right.
single thing.
Okay.
The only trouble you can get into is when n is negative. So if I give you negative 16,
Sure.
should you work on it as 2 times 2 times 2 times 2 times negative 1 or not? Well, that depends a lot on the assumption about the context of this code. But assuming we're dealing with non-negative numbers, this is fine.
Okay.
Yep.
Can you explain the print f?
At the prompt, it shows it.
It just shows it on the screen, because you want the user to be able to see the actual output of the program. So that's what printf is really about, is just show the result on the screen. Or some other form, print it out.
So I was a little bit confused about why you chose the while instead of a loop until. The pre is opposed to the post checking.
Because n is already initialized when I first get it. It does not need to go through the loop at least once for n to be meaningful.
Okay, so it's doing the check before you have to do the whole. Okay.
If n is not initialized or has no meaning or it's not ready for the comparison, when we first get it, then you have to use a post-checking loop because you have to go through at least one iteration. But in this case, we don't. Are there any questions about this? No questions? Well, here's the next question. Can we test this code? I mean, can we actually test the code and see whether it works or not? Yes. The answer is yes, we can actually test it. Okay, so we'll go ahead and go through a very simple trace of this algorithm, and just to give us a good feel that it's actually going to work. But Tech, this is something that's strange. It doesn't map to anything that we have already done. But can you understand it and actually do it with at least smaller prime numbers? Yeah, we can do that. Okay, so we'll go ahead and test this algorithm using a spreadsheet. So we'll go ahead and close this one. This one is already uploaded, so we can close it. And we'll start with a new spreadsheet. And okay, we don't need that one either. Okay, so let me see if I can just copy and paste it. Yep. All right. So we're going to give it line numbers. Start a new window for the trace itself. It's not going to be a very long trace. We'll start with loop. I offset my finger a little bit, and that's what happens. And then we have n as a variable, and f is also a variable. F is unknown to begin with. It doesn't have to start with anything, but n has to be given because that's the number that we are trying to factor. We'll try something like maybe 39 here. Okay, and line number is pre because that's the precondition. Because I need to have specific values to start the algorithm in this case. Are we okay with this? This is just one test case of the loop here. We start with line 1. N is greater than 1 is true. We go to line 2. Oh, line 2 is the mysterious operation. Find a prime factor f of n. Tell me one prime factor of 39. 3. All right, excellent. Okay, on line 3, line 3 doesn't do anything to the variables, okay, because we're just printing it. So the way we do it in this class is we just say print the value of 3 in this case because f has a value of 3. Are we doing okay so far? Okay, so we just use the comments, to indicate, whatever we are printing to a printer or the screen or whatever. Then we go to line 4. Okay, tell me what's going to happen on line 4. N becomes 13. Okay, yep, 13. And then where do we go? Back to line 1 because it's a pre-checking loop. Once we're done with the body, we go back to the beginning. N is greater than 1 is true because it's 13, right? Then we go to line 2 again. Find me a prime factor f of 13. What is a prime factor of 13?
13.
Is 13 itself. 1 is not a prime number, so it's 13 itself. Okay, so 13 itself is the prime factor of 13. Then we go to line 3. We print 13 to the screen because we're printing the value of f, and f has a value of 13 at this point. Then we move on to line 4. 13 divided by 13 is 1, so n gets updated to a value of 1. And then where do we go? Back to line 1. N is greater than 1 is false. You know what? We're done. All right. So the algorithm seems to work. Okay. It's just that it has that one little mysterious component called find a prime factor f of n. Okay. We still have about 3 minutes. Okay. So 3 more minutes. I know you guys are eager to go to lunch or next class or whatever. Okay. Or the dev club meeting. Don't forget yeah.
That's where we're going.
Yep. That's what you're thinking. Maybe not where you're going. Alrighty. So that's good. I mean, that's great. So maybe we are done with this algorithm. Are we? We're not quite done yet. Okay, because we have this operation called find a prime factor f of n that is abstract. In other words, we're not quite describing how it is done. We're just describing what needs to be done. Okay, so that means the next step is to just focus on find a prime factor of f of n and figure out how that can be done with all the constructs that we have talked about in this class. Okay? We have every single component that we need except for one thing. Okay? That one thing that you need is called a mod operator. Okay? And since we only have 2 more minutes left, it's just enough time to explain what a mod operator is. Okay, so A mod B is the remainder of A divided by B. That's all it is. Okay? Most of the time when you look at A divided by B, you get the quotient of the division. Mod, which stands for modulus, is the remainder of the division. So just to confirm that you understand the concept, we get another minute and a half. 17 mod 4 is what? What is the remainder of 17 divided by 4? 1. Good. Let's try another one. Let's try 28 mod 4. 4 is good. What is the remainder of 28?
0.
0. Very good. Let's try something tricky. 2 mod 5.
2.
It's 2. Very good. I am impressed. 2 divided by 5 has a remainder of 2. Has a quotient of 0, but a remainder of 2. Does it make sense? I have 2 candies. There are 5 kids. I have to divide the candies, evenly, but whole to the kids. So I just basically tell the kids, sorry, that I only got 2 candies, so I'm keeping both candies, and you guys get none each, right? It's still fair. The 5 kids gonna come back to me and say, well, how come he is 3 and I only get 2? Yep, I'm keeping both of them. Yep. Is that making any sense? Why 2 mod 5 is 2?
Yeah.
Okay, very good. So we'll start with this next time, on Thursday.
Homework time?
No homework at this point.